Let's take a look at the homework for L'Hopital's rule. I'm not necessarily going to do all of the problems, but hopefully I'll do enough to get you started and make sure that you understand what you're doing with L'Hopital's rule. The most important thing is to remember that L'Hopital's rule is simply one limit strategy. It's one strategy that can be used under the right conditions to find a limit, and a limit is simply a y value that is being approached on a function as you approach a given x value. So when you look at this problem, now we know it's part of L'Hopital's rule homework, but what you really should do when you're finding the limit of this rational function as x goes to -2 is you should follow your normal limit strategies, and the first limit strategy is to use direct substitution. And then what you would determine by that direct substitution is that you get a 0 in the numerator and a 0 in the denominator. At that point, that would tell you, oh, now I can apply L'Hopital's rule. Very important that you remember that when you are using L'Hopital's rule, you have to show that the limit as x approaches, in this case, -2 of the numerator. So notice I'm doing the numerator totally independent of the denominator. By substituting 0 into that, I will get 0, and I have to show that on my paper, and I have to show it totally separately from the limit as x goes to -2 in the denominator. So this is the first phase of L'Hopital's rule that allows me even to apply the rule. I'm showing that the conditions are met. So by substituting -2 into the denominator, I get 0 again. Now I can move forward and apply L'Hopital's rule. L'Hopital's rule says, under these conditions, find the limit as x goes to -2, take the derivative of the numerator, which is 3x squared, plus 2x minus 1. Take the derivative of the denominator, which is 6x plus 5. Substitute again, see what happens, and you will get 3 times -2 squared plus 2 times -2. I'm simply substituting the -2 in place of all of the x's. 6 times -2 plus 5. Do the arithmetic. That'll give me 12 minus 4 minus 1, which is -7. And then in the sorry, that's not -7, that is +7. Then I'm going to substitute or do the arithmetic in the denominator. 6 times -2 is -12. -12 plus 5. There's my -7, which gives me -1. So the y value that this function, if we were to see the graph, and you can actually do that on your calculator just to validate that, or do it on Desmos, and see that the y value being approached as you go to an x value of -2 is a y value of -1. Problem number 2, same process. We're going to begin by showing that the limit as x goes to, in this case, 0 of cosine of 2x plus pi plus x plus 1. If I substitute 0 in place of x right here, I will get cosine of pi. Cosine of pi is -1. Substituting 0 here would give me 0, so -1 plus 0 plus 1 would be 0. Taking care of the denominator totally separately, limit as x goes to 0 of e to the x squared plus 2x minus 1. If I substitute 0 in place of the x here, I get e to the 0, which is 1. 2 times 0 is 0. 1 minus 1. There's my 0. So now I can call L'Hopital, which tells me continue, find the limit as x goes to 0. Take the derivative of the numerator. Be careful of the chain rule here. The derivative of cosine is negative. I'm leaving a little space because I know the chain rule is coming. Negative sine of 2x plus pi. The derivative of the inside, the derivative of 2x is 2. Moving to the next term, the derivative of the x is 1, and the derivative of 1 is 0. Derivative in the denominator, the derivative of e to a power is e to the power times, the derivative of the power. Substitute 0 in, so if I substitute 0 here, I will get negative 2 sine of pi plus 1. In the denominator, I will get 2 times 0, which is already going to make 0, e to the 0 plus 2. The sine of pi, that's the y value at pi, is 0 times negative 2 plus 1. This first term in the denominator is 0, plus 2 is 2. So graphically, the y value being approached on this function, and again, you can look at it on your graphing calculator or Desmos just to get a view of what's happening. L'Hopital's rule. Problem number 3. Same process all over again. So I'm finding, I'm finding the derivative, I'm finding the limit as x goes to 3 of the numerator, so that's ln x squared minus x minus ln of 6. If I substitute 3 in place of this x squared and in place of this x, that would give me 9 minus 3, which is 6. Ln of 6 minus ln of 6 is indeed 0. Show the denominator totally separately, always separate. Limit as x goes to 3 of x plus 4 times x minus 3. And as soon as I substitute 3 here, that's going to give me a factor of 0, which is going to give me 0. Bringing in L'Hopital's rule, find the limit as x goes to 3. Take the derivative of the numerator. The derivative, I'm taking the derivative of this term right here. The derivative of ln is u prime, so 2x minus 1 u prime over u x squared minus x. Ln of 6 is a constant. The derivative of a constant is 0, so the derivative of ln of 6 is 0. Then I'm going to take the derivative in the denominator. Now, instead of doing the product rule, I'm going to multiply this together and get x squared plus x minus 12. That's what happens if you multiply these two binomials together. When I take the derivative, I will get 2x plus 1. So now I'm going to substitute 3 in what I have left over. So if I substitute 3 here in this fraction, 2 times 3 is 6, minus 1 is 5. Substituting 3 down here, 3 squared is 9. 9 take away 3 is 6. So I have 5 over 6 in the top. In the denominator, substituting 3 down here, 2 times 3 is 6. 6 plus 1 is 7. And I can put that over, thank you, Miss Oliver, I can put that over 1. So then that becomes 5, 6 times 1 over 7, which gives me 5 over 42, which is B. Number 4. Change colors. Limit as x goes to negative 1 of e to the 1 plus x Again, substituting -1 here would give me e to the 0. E to the 0 is +1. Substituting -1 here, +1 and -1 would give me the 0 that I'm anticipating. Showing the denominator totally separately, no 0 over 0. Cosine of pi x over 2. Substituting the -1 in place of x would give me the cosine of negative pi over 2. And in my unit circle, negative pi over 2 is down here. The cosine is the x value, so that would give me 0 as anticipated. Then I'm going to apply L'Hopital's rule. Limit as x goes to -1. Derivative of the numerator, the derivative of e to a power is e to the power times the derivative of the power, and the derivative of x is just 1. In the denominator, the derivative of cosine is negative sine, don't forget the chain rule, of pi over 2x. And then the derivative of the inside, the derivative of pi over 2x is pi over 2. Substituting in the -1. So a -1 substituted here would give me e to the 0, which is 1. 1 plus 1 is 2. Substituting -1 here, I'm looking for the sine of negative pi over 2. That's a -1. A -1 times negative pi over 2 is positive pi over 2. So that's 2 times 2 over pi, which is 4 over pi. Number 5. Let me get myself a little more paper here. All right, number 5. L'Hopital says, find the limit as h goes to 0 of the numerator, ln of e minus h minus ln of e. If I substitute 0 here, that gives me ln of h minus, substituted into the wrong place. Can't substitute 0 for e, can you? All right, so if I substitute 0 in place of h, that would give me ln of e minus ln of e, which is 0. The denominator limit as h goes to 0 of h is, of course, 0. Calling on L'Hopital's rule, limit as h goes to 0 of. So now I'm going to take the derivative of ln of e minus h. Now remember, in this case, your variable is h. So when I take the derivative of ln, it's u prime over u. U prime over u. So let me highlight something here. The derivative of e, when I do u prime, the derivative of e is just going to be 0, and the derivative of negative h would be -1. So that's u prime over u. The derivative of the ln of e. ln of e is a constant, so the derivative of ln of e is 0. And then when I go to the denominator, the derivative of h is 1. When I substitute 0 in place of h, I get -1 over e, which is a. So all of these were dealing only with functions. I think on the next page, the next page, now we're going to move to tables instead of just functions. So let's go do a few of these, perhaps all of them. We'll see how it goes. The table above gives selected values of a twice differentiable function, which means that f has a first and a second derivative. In number 6, we're finding the limit as x goes to 3. So in anticipation of L'Hopital's rule, I'm going to find the limit as x goes to -3 of the numerator. So when I substitute if I'm going to substitute -3, I don't need the limit anymore, do I? So when I substitute -3 to determine the outcome, that'll give me f of, substituting -3 here would give me -6 minus 1 is -7. F of -7 is 0 from the table of values above. Now I'm going to go to the denominator, the limit as x goes to -3 of x squared minus 9. Remember that when you are squaring and you're substituting a -3, you have to put parentheses, so you do get 9 minus 9, which is 0. L'Hopital says now I can find the limit as x approaches -3. Take the derivative of the numerator. Don't forget the chain rule. The derivative of f is f prime. That's the derivative of the outside. The derivative of the inside is 2. Don't forget the 2, the chain rule. In the denominator, the derivative is simply going to be 2x. Now I can substitute 3, which will give me 2f prime of 2 times -3 is -6, minus 1 is -7, over 2 times -3. From the table above, f prime of -7, right here, is 6. 2 times 6 is 12. 2 times -3 is -6. And 12 divided by -6 is -2, which is letter B. Moving on to number 7, using the table of values. I'll set it up and then I'll go back up and get the numbers that I need. So we're finding the limit as x goes to -5 of f of x, which would be f of 5. And according to the table above, f of, okay, that was a -5. Thank you for those of you who pointed that out, but you couldn't tell me in the video. F of -5 is -3, and f of -3 is 0. That's from the table above. So I did f of -5 is -3, and then f of -3 is 0. Denominator, find the limit as x goes to -5. Denominator is 3x plus 15. Substituting in -5 gives me -15 plus 15, which is 0. Now we'll go to L'Hopital's rule. Be careful with your chain rule when you're doing the derivative here. So we have limit as x goes to -5. I'm finding the derivative of f of x. So this is my outside, this is my inside. So I'm going to start with the derivative of the outside f. So that gives me f prime, leave the inside alone, times the derivative of the inside. And since the inside is f of x, the derivative of that would be f prime of x. The derivative of the denominator is just 3. So that gives me f prime of f of -5 times f prime of -5 all over 3. I believe f of -5 is -3. f prime, go slow, of negative 3 is 9. All right, going back up, f prime of negative 5 is negative 1. Nine times negative 1 is negative 9. Negative 9 over 3 is negative 3. So that is using a table. Moving on to number 8, same scenario, but now we are using a graph. The graph of g of x is above. Use the graph to find the following limit. Notice they're saying if it exists. I don't know if it said that on the other ones or not, but that's sort of catching my eye this time. So let's see if L'Hopital even applies here. So I'm going to start with finding the limit as x goes to 4, that is a positive 4, of g of x minus 3. If I substitute the 4 in here, 4 minus 3 is 1, so that just wants me to find g of 1. G of 1 is here, which is 0. So far L'Hopital seems to be applying. I'm going to come over here on the other side and find the derivative of, the limit of the denominator. Limit as x goes to 4 of x squared minus 2x minus 8. That is a positive 4. Be careful. 4 squared is 16. 4 times 2 is 8 minus 8, which gives me 0, which allows me to invoke L'Hopital. All right, so L'Hopital would say find the limit as x goes to 4. The derivative of the numerator is g prime of x minus 3. Since the inside is x minus 3, the derivative of x is just 1, so the chain rule is already built in. Denominator gives me 2x minus 2. Substitute in the 4, so I get g prime of 4 minus 3, which is 1, over, substituting the 4 here, 2 times 4 is 8. 8 take away 2 is 6. So I need to find the slope at x equal to 1. The slope, g prime, the slope. So since this is on a line segment right here, the way that I'm going to find the slope is I'm going to rise 1 and run to the right 2. So the slope g prime of 1, or the slope of g at 1, is 2 over 6, which is 1/3, which is not an answer choice. So let's see if I made a mistake somewhere. Let me look at this carefully. Okay, so I found my mistake. Right, it was right back here, and you probably caught it when I was doing it. So I said the slope is a rise of 1 and a run of 2, so that would be 1/2 over 6 over 1, so that would be 1/2 times 1 over 6, which is 1/12. So if you caught me back here when I said that the slope was 2, good job for catching me, because the slope is actually 1/2. Rise of 1, run of 2. So the y value being approached would be 1/12. All right, let's look at the next page. Now, since these answers are already posted, I'm not going to do all of these. I'm going to look some that look a little different. We have just recently done one that involves a graph, so you should be able to use that as your model. Of course, you can come in and ask me more questions if you're not sure. We did one just a second ago that had a table of values. What I will warn you about is when you take the derivative of the denominator, be careful, careful, careful of the chain rule. We've done one like the third one. I do want to look at the fourth one because it has something that looks a little bit different. So we're going to look at this one right here. It says the differential equation. Remember, a differential equation is simply an equation that has a derivative. It just means it's a derivative. So the differential equation for the curve, so in other words, there is an original function whose name is y or f of x. This would be the original function. dy dx is the derivative of the original function, and this is what they're calling the differential equation. I didn't want that terminology, even though we've seen it before, I didn't want that to throw you for a loop. So let's go back into the problem now that we've reminded ourselves what that notation or that vocabulary indicates. It is known that f of 2 is 1, so I'm going to just record that over here, that when x is 2, y is 1, and f is twice differentiable. So I'm going to find the limit of the numerator as x goes to 2, and that's f of x plus x minus 3, which would be f of 2 plus 2 minus 3. F of 2, we said right back at the very beginning, right here, f of 2 is 1, plus 2 is 3, take away 3 is 0. And then we're going to check our denominator, limit as x approaches 2 of ln of 2x minus 3 would be ln of 2 times 2 is 4. 4 minus 3 is 1, and the ln of 1 is 0. So I'm going to now invoke L'Hopital. I'm going to do it over here. Limit as x goes to 2 of f prime of x plus 1, because the derivative of x is 1. The derivative of negative 3 is 0. In the denominator, u prime over u. So the derivative of 2x minus 3 is 2, so that's u prime over u, 2x minus 3. Substituting in the 2, f prime of 2 plus 1 over 2. Substituting in the 2 here, 2 times 2 is 4. 4 take away 3 is 1, so that works out nicely. Now I need to find f prime of 2. Remember, f prime of 2, this is f prime. dy dx is f prime. So I'm going to come down here, 2x, my x value is 2, over y, my y value, remember we have this, my y value for x is 1, so 1 plus 1, so 2 times 2 is 4, 1 plus 1 is 2, 4 over 2 is 2. So f prime of 2 is 2 plus 1 over 2. 2 plus 1 is 3. So the y value this function would be approaching, as we approach an x value of 2, would be 3 over 2. And let's see if we have anything interesting on the last page. I think these look fairly similar to ones that we have already seen, but I do think that this one right here looks kind of interesting just because of the chain rule action involved. So I think I'm going to do that one. And then if you have questions on any others, again, the answers are posted and the work is shown, but you're more than welcome to come in and see me for extra help. All right, so let's find the limit as x goes to 2 of the numerator. So that would be f of g of 2. Be careful, g of 2 is 4. F of 4 is indeed 0. Let's check out the denominator. Limit as x goes to 2 of g of f of x. So that would be g of f of 2. F of 2 is 1. G of 1 is 0, so now we can invoke L'Hopital with a nice chain rule action going on here. So limit as x goes to 2. taking the derivative of the numerator, the derivative of f of g of x, the derivative of outside f prime, leave the inside alone, times the derivative of the inside. Same thing with the denominator. The derivative of g is g prime, leave the inside alone, take the derivative of the inside, there's my f prime of x, and now we're going to substitute in all of the 2, so that'll give me f prime of g of 2 times g prime of 2, g prime f of 2 times f prime of 2. Now we go on our treasure hunt. G of 2 is 4, so f prime of 4. G prime of 2 is negative 2. In the denominator, f of 2 is 1. That's a parenthesis there, by the way. I think I'm making it worse. And then f prime of 2 is 6. Let's go this way. F prime of 4 is negative 3. G prime of 1 is 5. Negative 3 times negative 2 is 6 over 30, which is 1/5. So I hope these problems, working them out, was helpful. Again, the ones that I did not do, answers are posted, and you are more than welcome to come in and ask me for any help, and I'll be glad to support in any way that I can.